Hello everyone, myself Savitha, Associate Professor, Department of Chemistry, Marani Science College. In the earlier video on the chapter soaps, detergent and waxes, we have learned about soaps, detergent, mechanism of cleansing action, the differences between the soaps and detergent, and also the types of the soaps, detergents, and its classification. In this video, which is the last video in this chapter under general chemistry, we will be learning what are waxes, I mean the definition, the different types of the waxes, and with examples and a few functions of the waxes. Let us define what are waxes. Unlike soaps, waxes are simple lipid where we have an esterification linkage between a long chain high molecular weight fatty acid along with the alcohol. However, in the waxes, we do not find the alcohol glycerol, but we can have sterols such as cholesterol. So, the waxes are the ester linkage between a fatty acid which has a very high molecular weight with an alcohol, and that compound we call it by the name waxes, and hence these waxes are simple monoester, and here the both fatty acid as well as the alcohol portion of the waxes are generally saturated long chain molecules, means they do not have any double bond, and the number of the carbon atom is very huge, and hence we use long carbon chain molecule. And when we take the number of carbon atom with respect to alcohol, it can vary anything between 12 to 32 carbon atom. Unlike we had the glycerol moiety in the soaps, which had just 3 carbon atom. And upon hydrolysis, this waxes will give the long chain carboxylic acid and long chain alcohols. These are few examples for the waxes, and the first example here I am going to take is the cetyl palmitate, which is a component of a spermatogen, a wax that is present in the sperm of the whales. So here we have a long chain carboxylic acid and a long alcohol which are joined together by an ester linkage, and here the fatty acid is the palmitic acid, and the other common wax is the bee wax, and the molecular formula goes as follows: C25 to 27, hydrogen being 51 to 55, with an ester linkage, and the alcohol component having 30 to 32 carbon atoms, and the hydrogen can vary between 61 to 65. And chemically beeswax, we call it by the name Mericyl palmitate. As I said, it is an ester of palmitic acid, which is C15H31COOH, and methyl alcohol, where we have the number of carbon atoms to be 30, and the molecular formula being C30H61OH. So this is the structural formula for the bee wax. So in generally when I take the acid and the alcohol part of the waxes, they are linear long carbon chain, and the number can vary anywhere between 12 to 36 carbon atom, both in the acid component and the alcohol component of the waxes. And coming to the occurrence, these waxes generally they are found as a coating on leaves and stems, and because of the coating of the wax, it prevents excessive loss of water. And the classical example for a plant wax, carnauba wax, which is found on the leaves of Brazilian palm tree. And as earlier said, waxes have lots of application. And the carnauba wax is used in flow and automobile waxes. So this is an example for a plant wax. The second example here is beeswax, which is secreted by the bees to make the cells for honey and eggs. The other example for the wax is spermatic wax, which is found in the head cavities and bulba of the sperm whale. And many of these waxes they find an application in ointments, in hand creams, and a few cosmetics. And this is a tabular column where we have different type of the waxes, and this is the alcohol component in this carnauba wax, and this is the fatty acid component. And the other example here we are looking is beeswax spermatic wax. And this is the condensed structural formula. And as already said, the source for a bee wax is honeycomb, and it has application in the preparation of candles, shoe polish, wax paper, carnauba wax. This is the structural formula found in Brazilian palm tree, and this wax is used in furniture, cars, floors and shoes. The another wax, jojoba wax, which occurs in jojoba bush, have an application once again in the candles, soaps and cosmetic preparation. Coming to the general features of the wax, naturally occurring waxes are invariably mixture of several ester. They are widely distributed both in plants and animals. Coming to the solubility, they are insoluble in water but soluble in organic solvent, and the special property is they are highly resistant to the atmospheric oxidation, and because of the high molecular weight they have high melting point, chemically inert, and they are not digested by the fat splitting enzyme such as lipase. Because of this unique property, the wax solutions are have a wide applications. However, these waxes cannot be used for making the soaps since the alcohol that are produced are generally insoluble in water. And coming to the role of waxes, they act as a water barrier in insects, birds, for animals, and it also serves as a protective coating on fruits and leaves, and they have used to make cosmetics, candles, and ointments. Coming to the classification of the waxes, depending on the origin, whether the wax are produced in the plants and animals, we classify the waxes into plant waxes and animal waxes. So let us take the plant waxes. They are generally found on the surface of the leaves, stems, and fruits of the plant which are grown in arid regions. And these waxes that are present on the plant will protect the plant from dehydration and also protect the plant from the invasion of pathogenic organisms which causes the diseases. So here the main function is it protects dehydration and it also acts as a barrier so that harmful organisms cannot attack the plants. And the classical example under the plant wax is carnauba wax, which have a melting point around 80 to 87 degrees centigrade. And this is obtained from the leaves of carnauba palm of Brazil and contains several components. However, when we take the major component, it is malicyl cerotate, which is C25H15 bonded with an ester linkage with C31H63. Upon hydrolysis, we get cerotic acid, that is, and an alcohol, that is malicyl alcohol. And the characteristic property of Vanuber wax, that is, it is resistant to water, that is, water resistance, and it is highly tough. And this hard and chemically inert nature is used in automobile and floor polishes as a protective coating. And this carnauba wax is also used as a coating on carbon paper and mimeograph stencils. So this is all about the carnauba wax. Next, we are going to the animal waxes. When the waxes are found in the animal, we categorize them to be animal waxes. Coming to the occurrence, they generally occur on the surface of hair, feathers, skin, and once again they serve as an excellent protective coating and it also keeps either the feathers or the skin to be very soft and pliable. And majority of the animal waxes are from marine sources, especially from the sperm and bottlenose whales. And the another important example of animal wax is bee wax and wolf fat. So these are the few animal waxes and in detail we are going to learn the animal waxes and the first one here we take the bees waxes. So everybody are aware of the bees and we know they produce the honey and the bee wax once the honey is extracted some hard material is left out which is nothing but the bee wax and hence the source of bee wax is the honeycomb of the bees and the composition is cereal myrcetate and methyl palmitate. So it's a mixture and here the melting point varies anywhere between 62 to 65 degrees centigrade and this bee wax which is obtained from the honeycomb is used in the manufacture of shoe polish, candles and paper coating. And the second example under the animal wax we are going to look is spermaceti and this wax is obtained by chilling the oil which comes from the head cavity of the sperm whale and it mainly contains cetyl palmitate and it has a lower melting point that is 40 to 50 degree centigrade and coming to the physical characteristics it is a colorless odorless and a tasteless solid and hence this formative wax is generally used as a base for the preparation of ointments and cosmetics and it is also used in the manufacture of candles and the notes and it is an excellent lubricant for delicate instruments such as watches. So this is all about the spermaceti, the animal facts. Coming to the other example of the animal fats is Lelone or wool wax, and it is obtained from the wool of the sheep and forms an emulsion with water, and hence this has an application in the preparation of the ointments. Let us just recall a few physiological importance of the waxes. So the main purpose, either in animals or the plant, it acts as the protective agent on the surface. Thus, it minimizes the attack of the pathogenic organism either in the animals or on the plant. Apart from that, waxes when they are found on the feathers and hair, they make them to be soft and flexible. And when we take an aquatic animal, these waxes prevent the aquatic animal from becoming wet. And the important application in the plant kingdom is whenever we have a wax coating on the surface of plant, it protects from the excessive loss of moisture, that is the dehydration, and hence in the earlier slide I said these waxes are present in the plant which are grown in the arid region, means with a high temperature, and they also prevent the attack of fungi bacteria which causes the diseases. And the another major application is waxy coating on several fruits like apple, citrus prevent from dying out because it does not allow the loss of moisture, and hence for this reason this can be stored for a longer period of time, and these are a few physiological importance of the waxes. And these are the references for the this waxes. Thank you.